In this video, I'll be talking about imperfections in materials and how they impact mechanical properties. There are many types of imperfections that can be found in materials. You can have imperfections known as point defects that focus on specific atom sites, and these include things like vacancies, which is when there is an atom or atoms missing in the structure and leaving empty spots. Furthermore, another type of point defect are interstitial atoms, which are extra atoms in the structure. Other types of imperfection also include linear defects or dislocations that deal with rows of atoms that cause disruption to the arrangement of the atoms in a structure. Also, area defects, also known as planar defects, which focus on planes of atoms. Dislocations or line defects are an extremely important type of defect that have a great impact on mechanical properties. There are two types of dislocation defects. The first one is known as an edge dislocation, which is a defect caused when an additional half plane of atoms is placed into the structure as seen by the figure on the left. The second type is known as a screw dislocation, which results in the structure forming a spiral because of stress being applied in a parallel manner to the line where the dislocation is happening. This is illustrated by the figure on the right. To begin to change a material permanently, something known as plastic deformation is needed. For plastic deformation to happen, dislocations in a structure must begin to move. For a structure dislocation to move, it requires the stress or force of a particular area to be applied, which then causes something known as slip. In the figure below, you can see how as force is being applied, the dislocation is slowly moving towards the right. Dislocations have a great impact on mechanical properties such as strength, hardness, and ductility when they move. Looking at the mechanical property of strength, one way to strengthen the material is to create barriers that slow the movement of dislocations. This can be done in a few ways. One way is to decrease the size of the grain. By decreasing the size of the grain, it increases the number of grain boundaries or areas between each section of atoms shown by the top figure. This slows down dislocations since the dislocations must change the direction in which they are moving each time they reach a new grain boundary. Another way to strengthen a material is to slow down the movement of dislocations by adding impurities to the plane of atoms, which introduces a stress that opposes the movement of dislocations and concentrates the dislocations to a particular area. The bottom figure shows how the addition of the impurities can cause a stress in the surrounding atoms. Another way that dislocations can impact the mechanical property of strengths is through something known as cold work. Cold work is when you increase the density or amount of dislocations in a particular area. By increasing the number of dislocations in an area, it reduces the motion since the dislocations begin to intertwine with one another, which impedes the movement of other dislocations. Other mechanical properties are also impacted when increasing the strength of a material. For instance, the higher the yield strength of material, which is the stress in which plastic deformation or permanent change of material begins, the harder the hardness of the material is. Furthermore, the stronger material, the lower the mechanical property of ductility, or how malleable a material is. This means that the stronger a material is, the more brittle it becomes. Finally, a higher strength in the material results in a smaller toughness, since it takes less energy to break a material. For example, think of a ceramic plate which is quite strong, but when dropped it easily breaks, showing small toughness as well as low ductility. The following video showed how defects like dislocations can impact mechanical properties such as strength.